So today we're going to start chapter 5. We're going to cover section 1. And today we're going to learn about triangles. So first we're going to define what a triangle is. And a triangle is a figure formed by 3 segments joining 3 non-collinear points. The points where the segments meet are called the vertices or the vertex. So the segments are the sides and the angles are the vertexes. So we have vertices at A, B, and C, and then we have side lengths of AB, BC, CA. Again, remember we can use that little slanty looking L thing to indicate that we have angle A, angle B, and angle C here. Next, we're going to be classifying triangles or giving them names based on their side lengths. So the first name is a scalene triangle, and that's when no sides are the same. So we would have 3 different sides. An isosceles triangle has at least 2 sides that are the same. And then an equilateral triangle are when all 3 sides are the same numbers. Now, when you're classifying these, they're either going to give you congruency marks or they would give you numbers. So in that first triangle down there at the bottom, the scalene triangle, I know it doesn't have numbers. Again, you're not supposed to assume anything about figures. So more than likely they would maybe put some congruency marks here and show that they all have different congruency marks, meaning that they're all different. Or they may even have numbers. So you could have like a 5, a 7, and a 10. And that could be how you would classify it by looking at the numbers in the picture. For an isosceles triangle, it's either going to have 2 congruent marks like this, or maybe they might tell you that this side is 8, so then this side would be 8, and then maybe this side is different. Then for an equilateral triangle, all 3 numbers would be the same, or it would have congruency marks on all 3 sides that look the same. Now, one special thing to note about isosceles triangles is that every equilateral triangle, so every equilateral triangle, which is this one, is an isosceles triangle. Because if you notice, the definition of isosceles is it needs at least 2 sides. It could have 3, but if it asks you to give the most specific name, when they give you all 3 sides the same, you would tell me equilateral. But technically, it's also isosceles. However, you can't say that, but not every isosceles is equilateral. I don't want equal, I want equilateral. Okay, so not every isosceles is equilateral, but every equilateral is an isosceles triangle. This is where we might tie this into a true-false question or a sometimes, always, or never question. That wasn't recording. Okay, so again, remember, if you get a test or a quiz question on this, remember if it says classify the triangle, that you look to see, does it want you to classify it and give a name for an angle of a triangle or a side length? These are all classifications based on the length of the sides. The next slide, anybody still need this one? These names for triangles based on the angle measures that are inside the triangle. So when you have all 3 angles that are less than 90 degrees, that is called an acute triangle. So it's a cute little triangle. When you have one angle that's greater than 90 degrees, then it's called obtuse. All right, so an obtuse angle is one angle in the triangle that's greater than 90. A right triangle means that there is one angle that measures exactly 90. And then equiangular, that means all three angles have the same number. Now, we're going to be learning the theorem, and it's called the triangle Sum Theorem. And you probably have already heard that the three angles of a triangle always add up to be 180 degrees. So if I know that all three angles add up to be 180, and if they're all the same, all I need to do is take that 180, divide it by 3, and then each angle in my equiangular triangle will be 60 degrees. Now, on the test or the quiz, you might get questions where it just says, classify this triangle based on its angle measures. Now again, they would probably give you numbers here. So example, this could also be equiangular because notice 60 degrees, these are all acute angles. Now, it doesn't necessarily have to be all the same. Just remember, we would need numbers that are less than. So we could have like a 40, we could have a 60, and then this one could be 80. Notice how all three angles are less than 90 degrees. When you have a right triangle, you will have exactly one angle that's 90 degrees. For an obtuse triangle, one angle will be greater than 90. And then the other two, would be something that would add up to be 180. And we're going to learn all of this coming up. And then again, your equiangular, each one of these is going to be 60 degrees. An equiangular triangle is also an equilateral triangle. Now, it may also ask you to give the name of the triangle of both angle and side. So let's say I add some markings here to this right triangle. So notice all the markings are different. So I could also call this triangle a scalene right triangle. So each triangle will be able to be given two names. One name for its side lengths and the other one for its angle measures. So here is our official triangle sum theorem. And what this states is that the sum of the measures of the interior angles of a triangle is 180 degrees. So if I were to add up the measure of angle A plus the measure of angle B plus the measure of angle C, these three angle measures will always add up to be 180 degrees. So if I give you a triangle, and let's say I tell you this one's 80, let's add some numbers, 80, and let's say this one is 40. And again, remember, none of these are going to be drawn to scale. So if you look at this, you might think, well, that doesn't look like a 60-degree angle. Just know that you can't just look at the picture and assume how big it is. So if I were to have only given you two of them, then what you would have to do is add the two that you're given, get 120, and then subtract that sum from 180, and that will give you the missing angle measure. Now, I know sometimes when we start the triangles, sometimes students get confused as is the number a side length that's in the picture or is it an angle measure? Generally, the angle measures are always going to have the little degree symbol next to it. And generally, the side lengths are always going to be written outside of the triangle. The next theorem in this lesson is the exterior angle theorem. And this one states that the measure of an exterior angle of a triangle equals the sum of the measures of the two remote non-adjacent interior angles. That sounds like a mouthful. It's kind of a lot. But really all it's saying is the two remote non-adjacent. So what it means by non-adjacent are the two angles that are not next to that angle that's outside. So for example, this is the angle that they're referring to as far as angle, the exterior angle, that's going to be angle 1. And then angle A and angle B, these are going to be my two remote non-adjacent interior angles. They're inside the triangle and they're not next to angle 1. So in order to find the measure of angle 1, all I need to do is add angle A plus angle B. So let's say angle A is 40 and angle B is 60. To find the measure of angle 1, I am just going to add 40 plus 60, and that gives me the measure of angle 1, which is 100. Now, the way that they probably taught you in middle school is they probably taught you to recognize that we have a straight line here. This is a straight angle. So they probably told you first to maybe find the inside angle, and you could find this angle here that's missing by adding 60 plus 40 and then subtracting that from 180. And then the missing interior angle is 80 degrees. And then they would tell you subtract that 80 from 180, and then the outside angle equals 100. But it's a lot faster to use this theorem. Now, I'm actually going to write a proof for this theorem. Again, on a test or a quiz, you're not going to ask to you're not going to be asked to prove any theorems or corollaries or anything like that. But we will be doing a lot of proofs in this chapter. So what we're going to be doing is proving that triangles are congruent. So let me go ahead and just show you how we could develop a proof for this theorem. So again, I would write my statement column and my reason column. And we would use the same original picture. So let's say we have this triangle and it's got A, B, C, and then we could put 1 and 2 here. I'm going to add a 2 inside there for the interior angle. So what I'm going to be stating is my given is going to be the diagram. Now, again, when you're given proofs to write yourself on a quiz or a test, the given will be some kind of statement. We won't just give you a picture and say, hey, here it is. It'll be actually a statement. So I'm trying to prove this theorem. So my next statement is going to be using that triangle sum theorem. So what I can state here is that angle A plus angle B plus angle 2 equals 180 degrees. And that's the theorem I just learned, and it's the triangle sum theorem. Now notice I put a 1 and a 2 in there because technically where that C is located, there's actually 2 angles there. So I can't refer to anything as just angle C because I don't know which side I'm talking about, either the inside or the outside. So that's why I added 1 and 2 here to show the difference. The next thing I'm going to talk about is this straight angle here that makes up 1 and 2. So now I'm going to state that angle 1 and angle 2 are supplementary. And this is going to be my linear pair theorem. or postulate. I'm not sure what this book calls it, but it's either linear pair. In some books, they refer to it as a postulate or a theorem. Next, I'm going to show you what supplementary angles are, and I'm going to say angle 1 plus angle 2 equals 180 degrees. And the reason why I can state that is definition of supplementary. Next, I'm going to establish that angle 2 equals angle 2, and that's my reflexive property. We will be using reflexive property quite often in our triangle proofs. A lot of times it's going to be, actually not in our triangles, in our quadrilaterals, especially when we bring in some diagonals. But that's to come in the future. All right, then my next statement is going to be substitution. Now that I've established that 2 is going to be the same in either side of my equation. So now what I'm going to do is state that this, since it equals 180, is equal to this, because this one's also equal to 180. So I'm going to state that angle A plus angle B plus angle 2 equals angle 1 plus angle 2. And that reason is substitution. And then finally, my last step, which is going to show that triangle sum theorem, I'm going to subtract the 2 from both sides. And then I'm just left with angle A plus angle B equals angle 1, which is that exterior angle. So this would be the subtraction property of equality. And this is what I was trying to prove, was that exterior angle is equal to the sum of the 2 remote non-adjacent interior angles. So a corollary to a theorem is just a statement that can be proved easily by using the theorem. So the corollary for the triangle sum theorem is that the acute angles of a right triangle are going to be complementary. So if you think about it, we already learned that the triangle sum theorem stated that the 3 angles add up to be 180. So if I take that 180 and I subtract out the right angle, that leaves me 90 degrees for the other 2 angles. And if you remember that when you have 2 angles and you add them, and when that sum equals 90 degrees, then those are complementary angles. So always, the 2 angles that are not the right angle, they're always going to be complements. They're going to always add up to be 90 degrees. Now let's just try some application of all of this. All right, okay, go on. All right, so the first example, and there's 5 parts to this, is to state whether the triangle having 2 angles is either acute, right, or obtuse. So they want us to classify it based on its angle measures. So the first thing we need to do is figure out that missing third angle. And the way that we would do that is to take the 2 given angles, add them, and subtract from 180. So I'm going to add 55 plus 43. And when I add those, I get 98. Now, this isn't one of the angle measures. To find that missing angle, I need to take 180, subtract the 98, and my missing angle for this triangle is 82 degrees. So the 3 angles for this triangle are 55, 43, and 82. Now I have to go back and say, is this triangle acute, obtuse, or right? And because all three angles are less than 90 degrees, this would be an acute triangle. Next, I'm going to do the same thing. I'm going to add 43 plus 47. When I add those, I get 90 degrees. So to find my missing one, subtract it from 180, and the missing angle is 90 degrees. If you remember your corollary that we just learned to the triangle sum theorem, that when you have a right triangle, the other two acute angles will always be complements, and that's where this 90 came into play. So because I have a 90-degree angle, this tells me that this triangle is right. The next one, again, you're going to add 80 plus 75. That will give me 155. I take that 155, subtract it from 180, and my missing angle is 25 degrees. So now the three angles of my triangle are 25, 75, and 80, making this, again, an acute triangle. Again, don't use the sum. We're only looking for the three angles. Next one, I'm going to add 33 plus 33. That gives me 66. Subtract that from 180, and my missing angle is 114. 114 is greater than 90 degrees, so this is an obtuse triangle. And the last one, add 24 plus 66. This gives me 90. 180 minus 90, 90 degrees, so it's a right triangle. So when they give you two angles, you have to take the time to find the missing third one before you can classify. Now, instead of just giving you listing two angles, they're giving us pictures. So they want us to find in A here, they want us to find the measure of this angle A. So I actually have two separate triangles here. I have this one over here on the left, and I have this one over here on the right. Now, we're going to be getting into triangle congruencies. A lot of times when my students in the past have seen this picture, they say, oh, this looks like a bow tie. We're doing the bow tie proof. But here we're just finding missing angle measures. So what I need to do is figure out what this angle that's missing is first. And again, I can just do the same thing I just did. I'm going to take the two angles that they've given me, the 80 and the 50. I'm going to add them. When I add them, I get 130. And then I will subtract that sum from 180. And my missing angle is 50 degrees. Now on the other side of this bow tie, realize that these are vertical angles. Vertical angles are congruent, so the other side here, this angle is also 50 degrees. And now to finally get to the question they wanted me to answer, what is the measure of angle A? I can now take 50 plus 50, add them, subtract that sum from 180, and my missing angle is 80 degrees. So for example B, these are actually two congruent triangles. This is sort of leading us into what we're going to be doing here. So notice this has a congruency mark, so it matches here. And then this one is marked as a 40, and so is this one. So then angle A is going to match with this one, so it'll be 60. Now, if it asks you to find that missing red one, then you could have added 60 plus 40, got 100, subtract that from 180, and this missing red one here would have been 80 degrees. And so would this one. Part C over here. Again, we can match our congruencies. And then the 30s match. So then this missing angle is going to be 110. Now, if it wanted the red one, again, what we would do is add 110 plus 30 and then subtract from 180, and the missing one up here would be 40. One last example, and we're going to apply that triangle, that exterior angle theorem. So again, we would apply that exterior angle theorem by adding angle A plus the 80, set it equal to the exterior angle, which is 120, subtract 80 from both sides, and angle A equals 40 degrees. Now, the next one, let's go ahead and add in our given information to the picture. Now, they're asking me to find the measure of angle F, so I'm going to actually call angle F X, just so it makes my equation a little bit simpler. Because notice over here, they're telling me that this exterior angle, FEH, which is here, is equal to 3 times the measure of F. So I'm actually going to call this 3x. And then they gave me the measure of angle G, which is 100. So let's try this exterior angle theorem. And I'm going to set it 3x is equal to the 2 remote non-adjacent interior angles. So that would be x plus 100. Subtract x. 2x equals 100. Divide by 2. And x equals 50. And remember, we set the measure of angle F to be x, so the measure of angle F is 50 degrees. This exterior angle would have been 3 times that amount, so this one would be 150. And that is it for section 5.1.